Okay, I know it sounds like we're going to be going backwards here because we're doing 5.6 part B, even though the night before you watched 5.5. 5.6b is we're going to solve quadratics again, meaning ax squared plus bx plus c has to equal 0. It has to equal 0. But this time we're going to do it using the quadratic formula. Alright, now the quadratic formula, what it is it's x, because that's what we're finding. We're finding x-intercepts, or finding the x-roots, solutions, is opposite b plus or minus the square root of b squared minus 4ac all over 2a. Yes, this is a formula you have to memorize and know and utilize and substitute into and show, because a lot of times we forget this opposite b, we forget our symbols in between. If we don't use parentheses right, our square doesn't come out right, and it's all over 2a, not just the square root part. So the examples we're going to look at, y equals x squared plus 13x plus 30. What's important here is that the equation has to equal 0. So if I have a y, I can just replace the y with 0. And the reason I get to do that is because I'm finding x-intercepts. And when I find x-intercepts, every value on the x-axis has a y-coordinate point of 0. So if there's a y there, you can just change it to a 0. If there's a number there, well, then you have to move the number. And if there's a 0 there, well, then you're already good to go. So in this case, you do have to tell me what is A, what is B, what is C. You do have to show me your substitution. Opposite B plus minus B squared 4AC all over 2 times A. And for the most part, you're going to have to show work, because not everything's going to come out to nice whole numbers. If it comes out to nice whole numbers and your calculator works, that's fine. But we don't use decimals. We don't use mixed numbers. And a lot of times we are going to come up with radicals and imaginaries, so your calculator will not work. So we're going to go through this showing all the steps. So I get negative 13 plus minus 169. And then 4, 1, and 30 is minus 120 all over 2. So I get minus 13 plus minus 49 over 2, which is minus 13 plus minus 7 all over 2. Well, that's the same as saying negative 13 plus 7 and negative 13 minus 7. Well, minus 13 plus 7 is negative 6 divided by 2, which is negative 3. And negative 13 minus 7 is minus 20 divided by 2, which is negative 10. So the solutions are negative 3 and negative 10. So they do come out to whole numbers. That means I could have factored this. However, when numbers are bigger or whatever and we don't quite see it right away, we need to have other ways to solve, and one way is to be able to use this quadratic formula. So let's try an example that doesn't come out to a nice whole number. What if I have 4x squared minus 3x is equal to negative 6? First thing you have to do is you do have to move the 6 so that it equals 0. It does have to equal 0. Then you can tell me what is A, what is B, don't forget the sign, and what is C. You do have to show me the substitution. Opposite of B plus or minus square root B squared. Be careful if you're using a calculator. Parentheses, minus 4 times A times C all over 2A. So here we're going to get 3 plus minus, and we're going to get 9. 4 is 16 times 6 or 24 times 4, whichever way that you want to go about it, we get 96. 9 minus the 96 is negative 87. Negative 87 cannot be factored, but the negative can. So it's imaginary. Square root of negative is imaginary. All over 8. And we just leave it that way. Don't separate it out. Don't try to change it to anything. Leave it the way it is. So that's an imaginary answer. We saw a whole one. So let's see what else we can do here. I have 2x squared plus 17 is 59x. Okay, so again, I need to put it in the proper order. So I'm going to have 2x squared minus 59x is equal, plus 17 is equal to 0. So here we're going to get opposite of b, plus or minus square root, b squared minus 4 times a times c, all over 2 times a. So 59 squared minus 4 times 2 times 17 is going to come out to a really big number. We'll try to see if we can't factor that down. Let's see, 3, 3, 4, 5. Let's see, we can get a 5. We can get a 3. And I think that's as far as we're going to be able to go. So we're not going to be able to reduce anything else. We're done. Finished. No more we can do. One thing I do want to point out, let's say that we get something and we have 2 plus minus, let's say 4 root 15 over 2. You would have to reduce this down. If whole numbers can be reduced, they have to be reduced. And it has to be everywhere or nowhere. So in this case, this would be 1 plus minus 2 root 15, because I can divide everything by a 2. If I had, let's say, 2 plus minus 3 root 15 over 6, there's nothing I can do. Because even though this 2, 6 reduces and 3, 6 reduces, they don't all reduce by the exact same thing. So there'd be nothing I can do. I'd have to leave it alone. Let's say I have 4 plus minus 6 root 3 over 2. All are reducible by 2. So I could 2 plus minus 3 root 3. All right, it's an all or none deal, and you do have to check, can you reduce, will it reduce, and if you can, you must. All right, that's your quadratic formula on 5.6.